Okay, so let's zoom out here. I do apologize in advance. I couldn't get the camera to focus more than this, but I assume that you all will be following along on your own practice test. So please follow along on your own practice test if you're not doing so already. Any weird background noise, that is my cat, and I do apologize in advance. But I wanted to come on here and explain the practice test for Unit 2 because the answer key is already posted by Dr. Filial, but some of these you may have questions about, and instead of waiting until our review session to get the questions answered, I figured I would go ahead and make this video, and then if you watch this video and do the questions before our review session, I can answer any more in-depth questions on Tuesday. So that review session is going to be Tuesday at 3:30 in the Buck Stop. Okay, so without further ado, we're going to get into question 1. So if you're following along and reading along with me, question 1 states, use the graph of f of x shown below to answers part A through D. So we have this graph here, and before we even look at the questions, what can we tell about the graph? Well, first we can tell that the graph is a polynomial. So that's important. Obviously, we learned about how to tell if graphs are polynomials or not. The reason why this graph is a polynomial is because you can see if it didn't have all of these waves in it, it would be parabola shaped, and it doesn't have any sharp turning points. All of these turning points are smooth and not sharp as you would see in like an absolute value. So that was a bit of just extra information for your knowledge. When I first look at a graph, the first things I try to discern are going to be what are my x-intercepts. In class, we learned x-intercepts are also called zeros because when x is a number, y is 0. So it's everything along your x-axis. So just so you all can see a little bit more clearly here, what I am tracing over in pink is going to be our x-axis. And what I'm going to trace over in this teal color is going to be our parabola-shaped polynomial. So you can kind of see it a little better now on camera, but like I said, please follow along on your own practice test as it'll be a lot more focused for you. So if we see here, we see that this polynomial is going to meet the x-axis at 4 separate points. Why does that make sense? Well, if we look here, we see 1, -2, 0, 3, and 5. So that's 4 times that this polynomial meets the x-axis. Now, what else can we tell about this polynomial right off the bat without looking at the questions? We can see it has 1 turning point, 2 turning points, 3 turning points, 4 turning points, and 5 turning points. So what we learned in class is that polynomials' degrees are always going to be 1 more than the turning points. Of course, you do get into some nuance if you have imaginary numbers. However, this specific polynomial does not have imaginary numbers on it, so you don't have to worry about that nuance. However, if we have 5 turning points, and we know the degree is going to be 6 because of that, then we know some of these x-intercepts are going to have multiplicities. So let's go ahead and list out our x-intercepts before determining their multiplicities. So our first x-intercept we come upon is going to be -2. The second one is going to be 0. The third one is going to be 3. And the fourth one is going to be 5. So that's -2, 0, 3, and 5. And that's what we highlighted up here. There's a good shot of it so you guys can see a little better. Now, we have our zeros written down on the chart. What we're going to determine is the multiplicities. The question does read, list the zeros / x-intercepts of x, or of f, along with their multiplicities. Note, there may be more room in the table than you need. So, what we're going to do is we're going to determine the polynomial's multiplicities of its x-intercepts. So, let's go over here to our graph. We're going to follow along the line we made until we get to 2, -2. -2, 0, we do see that that is kind of going back and forth because it's going to make that parabola shape. So because it's making that parabola shape, we know that it bounced off of itself twice. So because it bounced off of itself twice, we're going to write a multiplicity of 2. And now we're going to go down, make a turning point, and we're going to hit the x-intercept 0. Now, this one continues on in a straight line. What does that mean? That means it does not have a multiplicity greater than 1. It did not bounce back on itself. And now we're going to follow up, and we're going to make another turning point, and we're going to head down to 3. Do you see how 3 is making that parabola shape again? That means that 3 also has a multiplicity of 2. And we're going to head back up, make another turning point, and we're going to follow straight down through 5, which means 5 has a multiplicity of 1. Now, because on our test we could get a polynomial that its x-intercepts have a multiplicity greater than 2 or greater than 3, which means it would show more than just the standard odd and even shape, which if you remember correctly, the standard even shape is going to be a parabola, and the standard odd shape is going to be that x to the 3rd power parent function. So it's going to look like this, just so you guys can see. So if on the test you do get a polynomial that has a multiplicity greater than 2 or greater than 3, the way that you can tell is because the line here in the middle of the shape is going to flatten out. Why is that? Because it's going to bounce back on that point more than twice or more than 3 times respectively. Now that I've kind of explained that nuance for you, just so you know that information for the test, let's jump down to question B. I'm going to go ahead and grab a different color here just so we can kind of separate our answers. It's also a little easier to see. So, is the degree f even or odd? And how do you know? Okay, so let's take a look at our endpoints here. So our endpoints are both headed down, and we can see that our polynomial makes a parabola-like shape with its endpoints. So because the endpoints are both facing the same direction, and because of the shape of the polynomial, we can determine that it's even. You can check yourself because the degree that you figured out while trying to figure out your 0 and your zeros and x-intercepts is also even. We're going to get down to that in question C, and I'll explain a little deeper. But for right now, all you need to know for question B is this polynomial is even. And how do we know? It's because 2 and 1 and 2 and 1 equals 6. So all of our multiplicities down here are going to equal 6. Also, this wasn't on the answer key, so when you are on the test, write that answer, the multiplicities add to 6. But if you need an easier way to tell before writing that answer out, the best way is to look at what that end behavior is doing and looking at that general shape. Alrighty, I'm just going to write that answer down here. So 6. Awesome. So now we're going to go down here to C. So C says, is the leading coefficient of f positive or negative? How do you know? Alright, so let's take a look back here at our endpoints, okay? So what do we know about even-shaped polynomials? We know that their traditional shape is going to look like this, a parabola. Which means, as f of x approaches negative infinity, f of x is positive infinity. as x approaches positive infinity, f of x is going to be positive infinity. So I'll say that again, just because I think I got a little mixed up on my words there. As x approaches negative infinity, which is on this side of the graph, our polynomial, if it is even and has a positive leading coefficient, is going to approach positive infinity when it's talking about y's. And as x is approaching infinity positively, our f of x is also going to approach positive infinity. And remember, that is for positive and even polynomials. What do we know about the polynomial in front of us? This is what we know. Our endpoints are both facing down, and our graph is even. So if we have an even polynomial and the endpoints are both headed towards negative infinity or facing down, then that means the leading coefficient has to be negative. So it is an even polynomial and the leading coefficient is negative. Why do we know that? Traditional polynomials that are even are going to face up. Polynomials that face down vertically flip due to the leading coefficient being positive or negative. If that flip happens, it's a negative coefficient. So let's go ahead and write that. So, as I said, the leading coefficient is going to be negative, and we know that because the graph is even and shows us that it has a vertical flip. Alright, so now let's go down here to question D. Question D states, write an equation in factored form. Factored form, not standard form, factored form, for f of x. Assume the leading coefficient is 1 or negative 1, and the degree is as small as possible. So this is really important. We're going to assume the leading coefficient is negative 1. Why is that? Well, we did determine that the graph is already a negative and even polynomial, which means if they're telling us that our leading coefficient has to be a coefficient of 1, and we know that the graph is negative, then we know it has to have a leading coefficient of negative 1. I'm going to change my color here. Alright, so let's go ahead and start writing this out. We're going to write f of x is equal to negative, and we're going to start by writing out sets of parentheses. So we have a set of parentheses here, a set of parentheses here, a set of parentheses here, and a set of parentheses here. That means we have 4 sets of parentheses, which matches our 4 zeros. Now from here, it's going to be pretty simple if you've done everything above correctly. So let's go ahead and start putting in our zeros. So if you have a 0 of negative 2, what we learned from Unit 1 is that when you put it back into factored form, we're going to flip that sign. Now, mathematically, the reason why that is because you would be saying that if x is equal to negative 2, to get x is equal to negative 2, you would have to had x plus 2 is equal to 0. And of course, to isolate x by itself, you would have had to then subtract 2 to get x is equal to negative 2. So just remember, when you're putting your zeros into factored form, you're going to flip the sign. So let's go ahead and start writing this in. So x plus 2, and now we have our multiplicity. What does a multiplicity mean when you're talking about factored form? Multiplicity is going to simply be when you have your exponent onto that factor. Why is that? Because that means that negative 2 appeared twice, as an answer twice. So we're going to put a squared there. Now we have our 0. Ironically, 0 is a 0 here. So we're going to do x plus 0. Now we did say it has a multiplicity of 1, so you don't have to write anything above that parenthesis. Alright, now we're going to go on to x minus 3. Remember, we're switching that sign. So it's x minus 3 because in our table above it was a positive 3. In our table above we also see that it had a multiplicity of 2. So because it has a multiplicity of 2, we're going to then put that, exponent there. Then we're going to go ahead over here and do x minus 5. Remember, 5 is positive. We're flipping that sign to negative 5. Okay, and that is going to be all for problem 1. I'm going to pause here and then go on to the next problem. Okay, hi everyone. So we are going to focus on the second page. This problem right here, problem 2, is going to be similar information to what we did with problem 1. And then 3 and 4 are going to be what we did a week and a half ago. So I'm going to just try to jog everyone's memory there. Important note, if you don't have a calculator, you're definitely going to need one for this section. Off to the side is my little answer key. But yeah, you definitely need a calculator for this section. And I have the TI-84. So use your TI-84s and let's get into it. So, number 2, find the end behavior, the zeros, along with the multiplicities of each, and the y-intercept of the following polynomial function. Alright, so that's a bunch of gibberish, mathematician gibberish. So let's figure out what is this problem really asking us to do. So, we need to find the end behavior. If you remember from on the first page, what did I say the end behavior was? It's when we have those polynomial equations and we look to see what they are doing on the graph. Where are the y's going? Are the y's going the same direction? Are they going opposite directions? What is the end of the polynomial doing? Zeros, obviously, are the x-intercepts, so it's when does x have a number and y equals 0. What is a y-intercept? A y-intercept is the opposite of that. So when does the x equal 0 and the y equals a number? So let's get into it. So first, the easiest thing to find from this equation we were given is going to be our zeros. So what are our zeros? Well, if we look, don't put this in parentheses for your answer. I'm just trying to keep it all concise together for the sake of demonstration. We have x plus 1, x minus 3 squared, x plus 4. So that gives us a 0 of negative 1, 3 with multiplicity of 2, and you'll write out with multiplicity for the sake of room on the paper. I shorthanded it. And then we have x plus 4, so that's going to be a negative 4. So I'll repeat that again. We have negative 1, 3 with a multiplicity of 2, and a negative 4. Now, why does 3 have a multiplicity of 2? 3 has a multiplicity of 2 because in the factored form of the equation, the x minus 3 is squared. So remember, if your factored out equation has a squared, a cubed, a to the 4th power on that parentheses, on that factor, that is that factor's multiplicity. It means that x-intercept showed up 2 times, 3 times, 4 times, and so on. Just exactly what we did on the first page. Okay, so now that we have our zeros, what is our degree? Now, our degree is simple to find out because it's already given to us in factored form. So if we add all of our exponents on our factored out equation, we will get the degree. So x plus 1 has an exponent of 1, so that's 1. X minus 3 has an exponent of 2, so that gives us 3. And then x plus 4 has an exponent of 1. So our degree is 4, because all of our exponents added together give us 4. And then what is our leading coefficient saying? So on this graph, we have a leading coefficient of -1. The 1's implied because there's no actual number there, but it does have a negative. So our leading coefficient is -1. What does that tell us about this graph? So if we remember from the previous page, it has a degree 4. That means this polynomial is even. So because this polynomial is even, it's going to be in that parabola shape, and the flip, so what that leading coefficient is telling us is that it has a vertical flip. So we're going to write vertical. And that is because the leading coefficient is -1. So in simpler terms, that parabola figure is facing down and not up. If it was facing up, it would be a leading coefficient that was a +1. Because it has a leading coefficient of -1, it's facing down. All right, so we have our zeros, we have our degree, and we have our flip. Let's go ahead and list out our end behavior. So to list out end behavior, you're going to start off writing x approaches negative infinity. F of x is going to be negative infinity. Now, why do I know that? Well, let's go ahead and draw out roughly what we think this polynomial would have looked like if we graphed it. It probably would have looked something like this. Okay? Obviously, I don't know exactly when those turning points are or anything like that, but the main point of this is just to see those end behaviors. Because what we said over here, the degree is even, meaning that y value is going to be the same, because the end behaviors are the same, because it's even. And the leading coefficient is negative. So because the leading coefficient is negative, and we have an even polynomial, as our x, our negative x, so negative x approaches negative infinity, that's on this side of the graph, that means that the y is also going to be approaching negative infinity. And as x approaches positive infinity, f of x, so y, is going to also be approaching negative infinity. So remember, if you have an even polynomial, the ends will be doing the same thing. If you have an odd polynomial, the end behaviors will be different. If you need more clarification on what this problem would look like with a odd polynomial and problem 1 as well, you can come to the review session Tuesday, and I would be more than happy to explain to you what that looks like. For the sake of time in this video, I'm not going to go into that. And also look at Newton Alpha and at the review for test 2. Those would be great resources for you, along with the study session. Okay, so the last thing that this equation, this problem, wants us to find is our y-intercept. So that is where the calculator is going to come into hand, because what do we know about y-intercepts? We know that y-intercepts are when x is 0. So what we're going to do is write out our equation. Y is equal to -0 plus 1, because we're going to replace our x variable with 0, times 0 minus 3 to the squared power times 0 plus 4. And you can just go ahead and plug that all in your calculator. You can do it like in your head, but I have trust issues, so I'm going to put it in the calculator. Okay, so we have 0 plus 1 times 0 minus 3 squared times 0 plus 4 with a negative in the front. That gives us -36. You guys can see my calculator here. And you're going to want to write your y-intercept answer as a coordinate pair because Dr. Filial has specified that that's going to be the correct form on the test. So to write it as a coordinate pair, you're just going to put 0 as x and y as negative 36. Okay, so let's move on to question 3. For question 3, let's read what it's telling us and pick out some important information. All right, so a frog leaps from a 4-foot high stump and lands on the ground with some distance away. The height of the frog in feet is modeled by the equation h of x is equal to negative 0.5 x squared plus 1.25x plus 4, where x is the horizontal distance from the stump. That's important. Answer the following. Okay, so before we get into A through C, there is something that I would like you all to remember, jot down. This is going to make it easier for comprehension about this problem. So I'm going to grab a sticky note and I'm going to show you because I don't have quite a lot of room on this paper. So for sake of consolidating room, I'm going to show you on the sticky note. So let's think. We have a real life example. We're not on a graph. We're not in a fictitious math universe here. We have a real life example. So we have a stump, and forgive me for my drawing because it's not going to be very good. And we have a frog, okay? This is our frog. Kind of looks like a spider, but hear me out. And this frog is sat on this stump, and we know this stump is 4 foot high. He's going to take a leap off this stump and hit the ground at some distance, okay? And what we're trying to find is the horizontal distance from the stump. Right? That's what this equation is representing. Now, what do we see here in this drawing I made? We see that it's making a parabola-shaped figure. Obviously, it starts from where the frog is going to jump off, and that's going to be relevant when we get down to part B, so I'll come back to that. But let's go ahead and take a look at question A. Find the vertex of this function and explain what it represents in the context of the problem. Round your answers to the nearest tenth. And it says round your answers. So that's going to be every answer we get in problem A, we are going to round to the 10th before continuing on. All right, let's go back to my sticky note over here. This is why I felt it was important to draw it out. Some of you might not recall what a vertex is, and that's okay. So a vertex on any parabola or any figure that we're working with in this problem is going to be the center of that parabola. Now, to find the vertex, that equation is going to be modeled by x is equal to negative b all over 2a. This is important. Write it off to the side so you remember. And let's go ahead and start jumping into some math here. So let's go back to our equation up here. What is our b value? Well, if you guys remember, this is a, this is b, and this is c. So our b value is represented by 1.25 all over 2 times our a value. Remember to take that negative with you. Negative 0.5. All right, and one thing that I was leaving out, we're going to put a negative in front of our b value. So we have negative 1.25 all over 2 times negative 0.5. Now, I do have an answer key off to the side, so to spare us some time, I'm not going to plug it into my calculator, but the answer is going to be x is equal to 1.25. All right, so we found the x for our vertex. Now, this is where it's important. This question does want us to round to the nearest tenth. So in that case, x is going to be equal to 1.3. Now I'm not going to explain in-depth rounding rules, but as a general rule of thumb, if you're trying to round, remember that this value, if it's 5 or above, you're going to round this value up 1. If it's 5 or below, you're going to round it down, or like just keep it the same value. So if this was like 0.24, it would just be 1.2. All right, if you need more clarification on that, Khan Academy video. So now we're going to find the y of our vertex value. So how do we find the y? It's very similar to how we found the y-intercept. We're going to plug in our x value that we just found, because when x is 1.3, what is our y? That's what we're trying to figure out. So y is equal to negative 0.5 times 1.3 squared plus 1.25 times 1.3 plus 4. Now, if you do that in your calculator, you're going to reach 4.78, which rounded is 4.8. So, to write your vertex as a coordinate pair, your answer is going to be 1.3 and 4.8. So our x is 1.3 and our y is 4.8. So it does ask us to explain what this represents. And what this is going to represent is when the frog is 1.3 feet away from its stump, the height is 4.8 feet. So going back to my sticky note example, what we just found is when the frog is at 1.3 feet away from the stump, so that x value, it's going to be in the air at 4.8 feet high. Okay, so I'm going to set this to the side for right now. We'll come back to it in a second. Let's go ahead and start looking at B. So, B reads, find the zeros of this function and explain what they represent in the context of the problem. Now, what do we know about finding zeros or x-intercepts? We know that there's quite a few ways to find x-intercepts given what our equation is. Now, this equation, the easiest way, and probably the only way in this case, to solve for the zeros is going to be using the quadratic formula. Now, for sake of paper, I'm going to write the quadratic formula down here. So it's going to be negative b plus or minus the square root of b squared minus 4ac all over 2a. That's the quadratic formula. So let's go ahead and start plugging that into our equation, or our equation into the quadratic formula. So x is equal to negative 1.25 plus or minus the square root of 1.25 squared minus 4 times negative 0.05 times 4 all over 2 times negative 0.5. Now, you're going to plug that into your calculator. Do it in separate parts to simplify. So when you plug it into your calculator, you're going to simplify the 1.25 squared minus 4 times negative 0.5 times 4, and you're going to separately, and then you're going to simplify the 2 times negative 0.5. And then you're just going to rewrite once you've simplified. So once you've simplified in your calculator, you're going to get something that says x is equal to negative 1.25 plus or minus 3.09. Yeah, you can go ahead and simplify that square root because we're dealing with a real world equation and everything like that, and it wants us to find the answers. So go ahead and simplify that square root all the way down. And all over negative 1. Now, this is where we can solve for our two separate values. So we're going to plug this into our calculators, negative 1.25 plus 3.09 all over negative 1. Excuse me, I'm getting a phone call. Okay, and then you're going to plug it into your calculator, negative 1.25 minus 3.09 all over negative 1. That is going to equal 1.84 and 4.34. I don't have enough room to write it here, but basically what this is going to mean, so in the context of the problem, what do these zeros mean? So we have a negative x value and we have a positive x value. If we look back at our little diagram here, what cannot be true? We cannot have a negative x value, because if we had a negative x value, it would mean the frog was off of the stump or like inside the stump. That doesn't make sense. So the only value that can be true in the context of this problem is going to be our positive value, which we just wrote is 4.34. So essentially what you're going to write on your paper for this is going to be the frog lands 4.34 feet away from the stump, and negative 1.84 has no reasoning for being in the problem. So it has no, like, it doesn't apply. Okay, so now we're going to go on to C. So for C, it says, find the y-intercept of this function and explain what it represents in the context of this problem. All right, so find the y-intercept. Well, this is really simple. We've been finding y-intercepts. So what you're going to do is y is equal to negative 0.5. You come upon an x. What did we say we plug in for x when we're finding a y-intercept? We find 0 plus 1.25, 0 plus 4. Now you're going to plug it all into your calculator, and you're going to find y is equal to 4. So our y-intercept is then going to be a coordinate pair of 0 and 4. Now, if you want to save yourself time and you don't want to plug that into your calculator, there's a really, really simple way to find this. What do we know about zeros when we multiply? If you multiply any number by 0, it's 0. So this is 0 plus 0 plus 4. 0 plus 0 plus 4 is equal to 4. So we have 0, 4. All right, so what does this represent? That is going to represent the starting height of the frog. So if you want to think of it like this, it would be how tall is the stump? That's when the frog would start, right? Okay, so now we're going to move down here to question 4. I'm going to pause and readjust my camera. Alright, so I readjusted my camera and I got a sip of water. So I'm going to just move that back slightly. Okay, so now we are on question 4. So let's go ahead and read it. Robert wants to fence in a regular goat pen against the side of his house. That is super important. Using the wall of the house as one side of the pen. He has 480 feet of fence. Find the dimensions of the pen, which will give the maximum area. You must define an appropriate function for area and clearly show your work to receive credit for this problem. So, we're going to go down here. We're going to just draw this pen, this theoretical pen. So we know this, excuse me, it's not a straight line. This is going to be his side of his house, okay? And then this is going to be the pen in which he wants to create. So we have a rectangle. What do we know about rectangles? We know rectangles are going to have the sides equal the same. So in this case, it's x. And if x is the sides, then this length here has to be 480 minus x, or 2x, because we have two sides. So you would be taking essentially what that means as 480 minus 2x. So those sides added together because you want to find that length. So now we're going to take that over here and write out x times 480 minus 2x. And that's going to be our area equation. Why is that? Because area is length times width. So this is our length x times our width, right? So length x times 480 minus 2x. And then we're just going to distribute. So area is equal to 480x minus 2x squared. Let's go ahead and rewrite that. So area is equal to negative 2x squared plus 480x. Now we're going to solve for our vertex in this equation using negative b minus 2a, which we used up here. So that is going to be negative 480 all over 2 times negative 2. So x is going to be equal to 120. That's what you'll get if you plug that into the calculator. So let's go over here, and we know that this is now going to equal 120 on both sides. That's important. So we have 480 minus 2 times, so I write this, minus 2 times 120. So after all of that, if you put that into your calculator, you're going to get 240 feet. So your answer then becomes, you have a length of 120 times a width of 240, and it's in feet. And there you go. That's the answer for this problem. All right, so we have now moved on to the third page, and let's go ahead and read what question 5 is asking. Question 5 says, simplify each expression. Now, I'm going to show you all how I simplify square roots. If you have a different way, by all means use it. This is the way that works for me personally, and so I'm going to go ahead and show you guys that. So, first we have the square root of 20. Now, what times what equals 20? Well, I know 4 and 5 equal 20. Now, can any of this be broken down further? Well, I know 4 can, to 2 and 2. And when you do my method, so I think it's called factoring tree. Don't quote me on that, but this is my method. This is the way my dad taught me. So if you have 2, right, you can take them out, and it becomes 2 square root 5. That's the answer. Now let's go ahead and see how it works on this side. So we have 2 times the square root of 150. So we're going to leave that 2 out for a second. We're going to work on the 150. So the 150, the best way to simplify it is going to be finding, greatest common factors, and what times what is going to equal 150, but you want to find the greatest numerical values, just because it's going to be easier for you in the long run than dividing by 2 every time. So you're going to want to do 25 and 6. Now, what do we know about 25? It's a perfect square, and it breaks down into 5 and 5. So you can see there's 2 5s, so we're going to take that 5 out. So it's going to become 2 times 5, because we're bringing back that 2, to the 6th root. So it's going to be 2 times 5 times square root 6, because that's what was left in our little factoring tree. So 2 times 5 is 10, square root 6. That's your answer. 10 square root 6. For more clarification on breaking down square roots, watch Khan Academy, YouTubers. There's plenty of YouTubers out there that can help you with this. I'm not too terribly good at explaining this process, but I can also help you at the review session. Just let me know that you need help with it. Okay, now this C and D is where our imaginary numbers come into play. This is super important to remember. I squared is equal to -1. And the square root of -1 is equal to I. Okay, so let's go ahead and get into this. -5, we're going to leave it alone for right now because we're just going to bring that back in a second. We have the square root of a -40. Well, what can this be broken into? Well, we have a -1 because of an I, so it can be broken down into an I to make positive numbers, which would then be 4 and 10. 4 can be broken down into 2 and 2, and 10 can be broken down, but it won't factor out anymore, so we can just leave it as is. We're going to take out that 2. So it's going to be -5 times 2 square root 10, and you do have an I. So then, once you simplify it further, it's going to be -10I square root 10. That's going to be your answer. And then we have D. So D is going to be, there's a negative out front. We'll hold off on that for a second. It's going to break up into 4 and 10 and I, what we did just over there. And it's going to break into 2, 10 and I because it's a -20. 10 does need to be broken down this time because you then get 2 2s. So you can take them out. So it's going to be I'm just going to put -1 for the sake of you being able to see what I'm doing, times 2I square root 10 times 2I square root 5. Now this is where you got to separate these things in your mind. So anything under a square root is not impacted by numbers outside of square roots, but numbers outside of square roots are impacted by each other. So let's go ahead and simplify. -1 times 2I is going to be -2I times 2I is -4I squared square root 50, because you did 10 times 5. Let's come over here. So we're then going to have -4. Now, what did I say in the beginning about what I squared is equal to? I squared is equal to -1. And it's going to be square root 50. So then it's going to break down into +4 times whatever we're going to break out of the 50. For sake of room, I'm going to do it above here. It's going to look a little weird. So 5 times 10, and then 10 is broken into 5 and 2. So what do we get? 2 5s. So 4 times 5 square root 2. Let's simplify that down. Your answer is going to be 20 square root 2. Now, because some of you may be confused on where the I went, I'm going to explain it one more time. Those I's multiplied together, and when we're multiplying variables, the exponents add. So it's going to be I squared, and I squared is equal to -1. And -4 times -1 is +4. And that's how we got 4 times 5 to the square root 2 is equal to 20 to the square root 2. If you need more clarification on that, star it. We'll come back to it at the review session. Okay, so now this is completing the square. That's what question 6 is. when we are completing the square, one thing is always true. If we have a C value, we need to remove this C value to then put in what will be considered that equation's perfect square. Now, to remove 21, subtract it on both sides. So you're going to get f of x minus 21 is equal to x squared minus 10x. Wonderful. So we need to find what that C value then is. So remember, to find the C value, you take half of the B and square it. Half of 10 is 5, and squared is 25. So we're going to do plus 25. It's always going to be a positive because square roots make everything positive. Or, not square roots. Squaring things. Squaring things makes things always positive. My brain got mixed up because we just did square roots up there. But I digress. So whatever you do to this side, you always, always, always have to do it to this side. So you're going to do plus 25. 25 and 21 added together make a positive 4. So y plus 4, f of x and y are interchangeable, just so you know, is equal to x minus 5 squared. Okay? How did I get this x minus 5 squared? Well, because we now have this equation, we know that we need to factor that down. What times what can get you this, right? The easiest way for me to explain this is you're going to take half of that b again. Half of that b, x, so we're just going to take, we're going to break it up. So x minus half of that b, so that's going to be negative 5. So it's going to be x minus 5 squared. So that's why we got that. For further clarification, I can clarify on Tuesday, like I said. And then this is where we need to isolate y again. So we're going to do minus 4 minus 4. Your final answer is going to be f of x is equal to x minus 5 squared minus 4. All right, so let's go ahead and do this again for question B. So, question B. We are lucky because it does not have a C value. So we're going to jump straight into finding the C value. For this one, I'm going to keep everything as a fraction. Okay, everything's going to stay as a fraction. It doesn't tell us it has to be decimals, so we're going to keep everything as a fraction. So what is half of 5 squared? Half of 5 is going to be 5 divided by 2, right? 5 squared is 25, and 2 squared is 4. So, just so you all can see this, we're going to divide 5 by 2, and we're going to square it. And then you get 25 over 4. So you're going to add that on, 25 over 4. You make sure you do it on this side too, because remember what I said before, anything you do on one side, you have to do on the other. So we're then going to write this as y plus 25 over 4 is equal to x squared plus 5x plus 25 over 4. Now let's simplify it down further. We're going to have y plus 25 over 4 is equal to x, remember, take half of the b, so we're going to do plus 5 over 2 squared minus 25 over 4. Now, why did I put the minus 25 over 4? Because we're going to subtract 25 over 4 on this side, and it cancels out. So it's going to be minus 25 over 4. So y is equal to x plus 5 over 2 squared minus 25 over 4. All right, so that is all for that page. We're going to move on to the next one. Alright guys, so we are on the last page, and if you have stuck around this far, props to you. it's been a long video, but I really do hope it's helped you guys understand some of these more challenging concepts or things you just quite didn't grasp onto in class. So I'm going to stop yapping and get on to 7 and 8. So, question 7. Let's read what it says. Solve each equation and find exact solutions using radicals and I if necessary. So we're going to solve by using a few different methods. So I'm going to show you how I determine which method is the best to use. Let's look at the first equation. X squared minus 7x plus 12. We know it has an x squared, an x, and then a c by itself. That means the best way to solve this equation is going to be using the x factor. If you have a different way of solving these, by all means do it. It's just, this is the easiest way for me. So on the top of our x, we're looking for what c is. C is 12. What is b? Negative 7. So what multiplies to give us positive 12 and adds to give us negative 7? Now, in the answers, Dr. Phil y'all did have a different way that she got it, because negative 4 and negative 3 add to give 7 and also multiply to give positive 12. But same for negative 6 and negative 1. So both are true. You're going to write it out, x minus 6 and x minus 1. And when you FOIL them, it's going to equal that equation. Then you would set these to 0. So x minus 6 is equal to 0, and x minus 1 is equal to 0. You then would find the answers to be x is equal to positive 6, and x is equal to positive 1. That's your answer. All right, so let's go ahead over here and do the x factor here. So before we do the x factor, what is true about this equation? It's not equal to 0. So we're going to set it equal to 0. X squared minus 5x plus 6 is equal to 0. We just added, it's going to be actually plus 5x. We're going to add 5x to both sides to equal it to 0. Okay, so what multiplies to give us 6 and adds to give us positive 5? Well, that's going to be 3 and 2. So we're going to have x plus 3 times x plus 2. Now, most of you can do this math in your head. It's going to be x is equal to negative 3 and x is equal to negative 2. Just remember over here we set it equal to 0 if you do need to work it out for sake of time. If I did it in my head. So your answers are going to be x is equal to negative 3 and x is equal to negative 2. All right. Now we're going to come down here and we're going to do some more ways of factoring that can be a little bit more complex. All right, so let's take a look. We have 0 is equal to 2x squared plus 4x minus 3. Now, I just put 0 on the left side because it makes it a whole lot of easier than putting this on the other side. And it's both are true. It's going to be true either way. And then you just add 2x squared onto the right side to get your equation to look like this. All right, now, we know there is no common factor for all three terms. And so we also know we can't do the x factor to equal. We cannot find anything that is going to multiply to give us 3 and also add to give us positive 4. Think about it. If we need something to add to give us positive 4, we only have the options of 2 times 2. And 2 times 2 does not equal negative 3. So it doesn't work out. That being said, if all else fails, you can always use the quadratic formula. So we're going to have x is equal to negative b, so it's going to be negative 2 plus or minus, hold on, negative 2, no, negative 4, sorry, I was looking at C. I was thinking something was off. Okay, negative 4 plus or minus the square root of b squared, which is 4 squared, minus 4 times a, which is 2, times c, which is negative 3. It's going to be negative 4 plus or minus the square root of 4 squared minus 4 times 2 times negative 3, all over 2 times a, which is a positive 2. Alright, so we're going to simplify that out using our calculator once again. And it's going to get us to x is equal to negative 4 plus or minus the square root of 40 all over 4. Let's go ahead and simplify that square root of 40. It's going to be x is equal to negative 4 plus or minus 2 root 10. And then that's going to be all over 4. Now, we got to root 10 because 40 breaks into 4 times 10. And remember, you can take the square root of 4 outside of the square root to equal 2. So that's 2 square root of 10. And then once you simplify that down, we do see there's a GCF amongst all of the terms outside of the square root. That's going to be a 2. So if you take that 2, everything's divisible by 2, you get rid of this, you bring that down to negative 2, and you bring that to positive 2. So your answer is going to be x is equal to negative 2 plus or minus the square root of 10 all over 2. I had to put it up here because this morning had a room. But as you can see, we're just going to divide this whole section here by 2, cancels that out, and brings these down to 2, just so you can see it in real time. All right, let's go ahead and split up this so we make it a little bit more clear. Now we have x plus 1 squared plus 5 is equal to 1. So what we're going to do here is we are going to factor using the square root method. So in order to do that, you're going to isolate this square, right? So you're going to do x plus 1 squared is equal to negative 4 because you're going to subtract 5 on both sides. And 1 minus 5 is negative 4. So then we're going to take the square root on both sides, cancels out to x plus 1 is equal to the square root of negative 4. So the square root of negative 4 is going to be 2 times 2 and then an I. So it's going to be 2i. Okay, excuse me, my camera fell. What I was saying is that the root 4, negative 4, is going to cancel out to be 2i, but you want to make sure you're always including that plus or minus outside of it. So plus or minus 2i. Now we're going to do x is equal to negative 1 plus or minus 2i, because you are going to subtract 1 on both sides to isolate x. So then your answer is going to be x is equal to negative 1 plus or minus 2i. Like that. Okay. So now we have e. E reads x third is minus 2x squared minus 9x plus 18. Now, we have 4 terms. That means we can factor by grouping. So let's go ahead and start factoring by grouping. Remember, you're going to take that negative in with you. So this is all divisible by x squared, and this is divisible by negative 9. So we have x squared times x minus 2 times negative 9x minus 2 is equal to 0. Now those should always match, because they're going to come into 1. So you're going to have x squared minus 9 times x minus 2. Now x squared minus 9 is going to be a difference of squares. So you're going to have x minus 3, x plus 3, and x minus 2. So your x's are going to equal 3, negative 3, and positive 2. Okay, so now we're going to go over to f, and with f, we can now do the x factor. Now, why can we do the x factor? Because there's 3 terms, and these exponents are even. So we're going to just go ahead and separate x squared, because we know we're going to have something that equals that x squared, right? So we're going to have something that equals 4 by multiplication and adds to give us negative 5. So that's going to be negative 4 and negative 1 add to give us negative 5 and multiply to give us positive 4. So negative 4 and negative 1. Now that's going to be x is equal to plus or minus 2, and x is equal to plus or minus 1. Now, why is it plus or minus 2? Because when you solve this to 0, it's going to be x squared is equal to 4. And to cancel out that square, we have to take the square root. So taking the square root is going to be x is equal to plus square root 4. And that would be x is equal to plus or minus 2. Same with 1, but we know the square root of 1 is 1. So x would be equal to, x is equal to plus or minus 1. That's why that's the answer. Okay, so now we're on to our last problem. I'm not going to solve 9 in the video. We have not gone over long polynomial division in class. So because we have not gone over 9 in class, I'm not going to go over it on the study guide. Once we go over it on Monday, I will then be available for any questions Tuesday, but just ignore 9 for now. We're going to just jump to 8, and then it'll be the end of the video. So, solve each inequality and write your answer in interval notation. Show all supporting work. So we're just going to factor like normal, like we did up here. So we're going to do x factor for this one. So what multiplies to give us negative 6 and adds to give us negative 5? Well, negative 6 and 1, because negative 6 plus 1 is negative 5. Negative 6 times 1 is negative 6. So we're then going to write it out, x minus 6 and x plus 1. And then, solve for x. So x is equal to 6, x is equal to negative 1. Then we're going to come down here. This is where it gets different from what we did above. We're going to draw our number line. Okay? So we have negative 1 and we have 6. So we know this is an even polynomial because our degree is 2. And we know that it has a positive leading coefficient. So we're going to draw it like this. Right? And we know that this is telling us x is less than 0, right? So when x is approaching, right, y, it's going to be less than 0. And when x is approaching, positive infinity, that y is going to be less than 0. I hope that makes sense. Basically what we're looking at is anything below the number line, right? So because it's not going off into infinity and it's connected via this turn, what we're looking for is anything inside this inequality. So between 1 and 6. And because it doesn't give us a less than or equal to sign, our brackets are going to be parentheses. So our answer is going to be negative 1, comma, 6. Because when x is approaching negative infinity, y is going to be between -1 and 6. Does that make sense? So it's telling us that we're looking at what's less than. So it's anything that's below. So this right here. That's why it's going to be -1, 6, because it's connected. We're looking at y's when we're talking about this. So then we're going to come over here and do it the same way. This one's going to be a factor by grouping, and it's ironically the same one we did up here. So to consolidate space and time, I am just going to go ahead and just write out what we did up there. So all that work is in question E. So we're going to do x minus 9, x squared minus 9, and x minus 2 is what that factors out to. So then you're going to have x is equal to -3, 3, and 2. So let's go ahead and draw out our number line. We have -3. Actually, it's going to be negative. Yeah. It's actually going to be a positive 2. It's going to be a positive 2. So, my bad. It's going to be -3, 2, and 3. This is obviously not drawn to scale. And what do we know about this polynomial? We know it has a positive leading coefficient, and we know it's odd. So what do odd polynomials look like drawn with a positive leading coefficient? They're going to start low and end high. It's going to look like that. Obviously, the turning points are probably not what it's going to look like, but bear with me. I'm trying to just draw. But it's what's important is the endpoints, okay? So I'm just going to redraw this really quick. So okay, that's what it would look like. Don't mind the middle section. So it's going to go through 3, through 2, through -3, through 2, through +3. So what we're looking at is when it's greater than or equal to 0. So if it's greater than, it's going to be above the number line. So we're looking at between -3 and 2, and from 3 to positive infinity. So we're going to write this as -3, 2, union 3, infinity. And infinities always have open parentheses. These are closed because it's equal to. So x, when it's above 0, it's going to be between -3 and 2, union, because there's nothing here, and it's going to be 3 to infinity. Does that make sense? Because it's going to get wider. So let me go back and explain this one really quick. I feel like I might have been a little confusing. The reason why this one doesn't have a union is because we know what y is when x is between -1 and 6. It's gonna be the numbers between -1 and 6. So you just write it like that. And that is gonna be the whole practice test explained. If you have any questions or are confused, you can come to the study session Tuesday and I'll explain it then. But I hope this video helped you all, and goodbye.